Lesson 1. The biological impact of ACEs. At birth, and even before they're born, children begin to interact with their environments. Their brains and bodies develop in response to interactions with the people, places, and things around them, and their early experiences start to shape who they are and who they'll become. This is why we must pay careful attention to the physiological effects that ACEs can have on children. And so in this lesson, we'll review toxic stress and discuss epigenetics as these factors relate to ACEs. You will recall from the introductory module that there are different types of stress that can affect brain development early in life. These different types of stress are positive stress, tolerable stress, and toxic stress. Importantly, adversity and stress are not always toxic. If stress responses are brief and buffered by protective factors like safe, stable, nurturing relationships and environments, they can build confidence and resilience. But if adversity is chronic, severe, or excessive, a toxic stress response may trigger biological and behavioral changes that act as risk factors for poor mental, emotional, behavioral, and physical health outcomes. No matter what type of stress a child encounters, it has the potential to become biologically embedded into their brain and influence adaptations to adversity in both healthy and unhealthy ways. Research shows that prolonged exposure to ACEs can result in toxic stress responses that may impede a child's development and produce changes at molecular, cellular, and behavioral levels. At the molecular level, we may see changes in gene expression. At the cellular level, changes in brain connectivity and immune function are possible. At the behavioral level, we may see changes like the adoption of coping mechanisms. And while many coping mechanisms are healthy and help reduce acute stress, some present risks to health and well-being, like smoking cigarettes, drinking alcohol, using other substances, or adopting risky sexual behaviors.
Positive stress is temporary. It helps you create motivation and resiliency. We all experience it. Learning toilet training, riding your bicycle, many things are normal stressors and have positive outcomes. But we have systems in our biologic brain, hormones that alert us, help us to arouse or calm down. And toxic stress, if you're submitted to intense, frequent activities or experiences that increase and maintain that level of hormones and alertness, is eventually can lead to maladaptive behaviors. And maladaptive behavior at the moment could be adaptive, could be relaxing. A kid who smokes pot to relax because he's in a lot of stress, he might look at that, this is a coping mechanism, not realizing that he's harming himself.
When patients experience toxic stress responses, they are at an increased risk for chronic health problems, shorter lifespans, and behavioral issues that can influence the next generation. Furthermore, toxic stress responses have high social costs, compounding the health, poverty, and law enforcement burdens that already strain our public services. It is both ethical and economically wise to invest in approaches that reduce childhood adversity and the effects of toxic stress among children. It's also the right thing to do biologically. This is because our brain plasticity, meaning the brain's ability to change, declines as we age. And as brain plasticity declines, it is more difficult to repair or remediate issues that occur as a result of ACEs. Although adults are still capable of change throughout their entire lives, it is far easier to intervene when children are young and their brains are able to change more easily. Now, let's turn to epigenetics. Whether epigenetics is a new term or something you reference frequently, it's important that we review the connection between epigenetics and ACEs. Let's start by defining epigenetics. Epigenetics is the study of changes caused by alterations in gene expression rather than changes in the genetic code itself. Just like the switches in an electrical box, our genes can be turned on and off. Some of our genes act as master switches. These genes can switch other genes on or off. Some genes have dynamic switches. These genes switch on and off frequently, like genes that exhibit a circadian rhythm and express changes over a predictable 24-hour cycle. Still, other genes have stable switches. These genes remain on or off throughout life. Epigenetics shows that social and environmental stimuli, the people, places, and things that a person interacts with, can switch certain genes on or off, altering the way our brains and bodies read our genetic code. And these epigenetic changes can have lasting impacts on our health, development, and behaviors. So, what does this mean in relation to ACEs? We now know that early childhood experiences can result in epigenetic changes. This helps explain why early adversity is linked to poor health outcomes and risky behaviors. When a child's environment is filled with adversity, epigenetic changes can cause certain genes to switch on or off, impacting their developmental and health trajectories in negative ways. Epigenetics also helps us understand that our genetic predispositions are not inevitable. For instance, a child may inherit genes that predispose them to depression or obesity, but that part of their genetic code may never be expressed if their environment does not cause that epigenetic mark to switch on.
So epigenetics involves the way that our genes are expressed given our experiences in life. So you may have a genetic predisposition toward a particular disease. However, that gene may not be expressed unless you're exposed to a stressor in life, such as toxic stress. We know that children who are exposed to toxic stress tend to get sick more often. They tend to have more issues with asthma, diabetes, obesity, as well as anxiety and depression, and this may impact their schooling as well.
Take a moment now to review.